Molecules. Most elements do not exist by themselves. When two or more atoms are bonded together, they are called a
molecule.
So here are some examples of molecules.
Like water.
Like water, right here, water. So oxygen with two hydrogens. It's supposed to be an H. And that's supposed to be another H, bonded to an O.
And carbon dioxide.
Carbon dioxide, here's the carbon, and it's bonded to two oxygens, so that's what the 2 is for next to the O.
Mm-hmm.
Yep. Here's methane. You don't need to know these others. But carbon dioxide and water we talk about all the time. Which one of the following is always a molecule?
Water.
Beautiful. Some molecules are large and complex, like aspirin. So these are 4 different ways to write the same thing. Aspirin you can write as C9H8O4, or you can draw the carbons in the way they are. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. So there are 9 carbons, and then you can draw in the hydrogens. Here they're doing it with colors, so the carbons are green, the oxygens are red, and the hydrogens are blue. If you notice this is really important. The carbons can make 1, whoops, that's really bad, 2, 3, 4 bonds. Here's another one, it's making 1, 2, 3, 4 bonds. Whereas oxygen only makes 2. There's 1, 2. Hydrogen only makes 1. So carbon's going to be really, really important for our study of chemistry. The first thing we should look at are chemical formulas, and I think most of you have looked at this before. A chemical formula shows the kind and proportion of atoms in each element that occur in a particular molecule. So for example, H2O, this means that there are 2 atoms of hydrogen
and 1 oxygen.
And 1 oxygen, because if you don't write a number there, you just assume it's the number 1. Davy, how many carbons?
There's 1.
How many oxygens?
2.
How about this?
6.
6 carbons. How many hydrogen?
12.
How many oxygen?
2.
Good. How about this? How many hydrogens are there?
8.
Good. The number before formula tells the number of molecules, so 3O2 represents 3 molecules.
Of oxygen.
Yep. But that's how many molecules. So this whole thing is a molecule. But how many atoms of oxygen would be 3 times 2 or 6? Good. Okay, 5CO2. This is your turn, Davy. So how many molecules of carbon dioxide are shown?
It's quiz time. How many molecules? 5.
Beautiful. How many atoms of carbon are present?
5.
Good. Didn't get tricked.
Definitely fooled.
How many atoms of oxygen are there?
10.
Nice. So how did you get that?
Because there's 2 oxygens in the molecule, and there's 5 molecules in total, so if you use multiplication, then you get 10.
Nice. Okay, here's sugar. This is a formula that you actually should memorize. It's glucose, C6H12O6.
There's 3 of them.
How many molecules are shown?
3. I answered it before the question.
I know, that's a little scary.
Psychic.
How many atoms of carbon are present in each, careful, in each molecule. So not in the whole thing. Yep, in each molecule there's 6. And then I bet you can guess the next question. How many atoms of carbon are present in total?
18.
Good, so what'd you do?
I multiplied 6 by 3.
Good. How many atoms of oxygen are present in total?
18.
Good.
Again,
3 times 6 is 18. Good. Which of the following are atoms, the way they are written here?
The first, A and E.
Good. Carbon and oxygen. Which of the following are molecules, not single atoms? Tell me the name of it.
Oh, molecules? Okay.
Yep.
A, which is glucose.
Good.
B, which is oxygen.
Good.
Well, yeah, there's no, I think that's
atmosphere, yep.
And
molecular
D,
oxygen.
which is water.
Good. So these are 3 formulas that my students should know. This thing is glucose. We'll talk about it so much. You really just have to memorize that formula. Oxygen, molecular oxygen is O2, and then water is H2O. Bonding. Most elements are not stable alone. Atoms undergo chemical reactions. They combine with other atoms in order to become more stable. This is because electrons tend to zip around the nucleus at certain energy levels. So these energy levels are something you'll spend a lot of time on next year when you do chemistry. 2 electrons can fit in the first energy level. So if you look at this, there's 2 electrons in that energy level. For sodium, there's 2 electrons, in this energy level. Carbon has 2 electrons. If you look at hydrogen, it only has one right now. Why is that, David? Do you know?
It's because, well, actually that's kind of the reason that it bonds
Yeah,
with
it
only
is.
one, because there's only one open space.
Okay, good.
And that's the reason.
Good. So hydrogen has only one electron in its first energy level. The reason is it's got only one proton in here, which is something that I would tell you you don't have to memorize that. And because it's got one proton, it's got one electron because they balance each other off. It needs
two.
It needs two to be stable. So here's what it does. This electron was from this one, and this electron was from this one. And if they both go around both, then they'll end up with, both atom will end up with two shared electrons. And so that's a covalent bond, and that's a really important thing. So it's shared electrons. 8 electrons can fit into the second energy level. So this one doesn't have an energy level. We won't even look at it. If you look at,
energy level.
Yep, in the second, did I say that?
No, you just said energy level.
Oh, this one has one energy level, thank you, but it doesn't have a second energy level. That's why I put an X. If you look at sodium, it's got 1, 2, 3,
It's got
4,
a third level.
5, 6, 7, 8. It's got 8 electrons in its second shell, so the next electron would go in the third shell. Now let's look at carbon. It's got 1, 2, 3, 4 electrons in that second shell.
Which is why you can make 4 extra bonds.
Exactly. So carbon has 6 protons altogether, so it's going to have 2 here plus the 4 out here. Makes 6. But it needs how many to make itself stable in this second shell?
4.
It needs 8 total, or 4 more.
Yeah, 4 more.
Good.
Sorry.
No, that's,
I
you
didn't
got
say
it.
that clearly.
You got it. So carbon has only 4 electrons in its second energy level. We don't worry about the inner energy level at this point. Just
because it's already full.
It's already full. Yeah, it's only the outer ones that will bond. So it needs 8 to be stable. And so here's what it'll do. It has these 1, 2, 3, 4 outer electrons. And let's change the color. And this one is from that hydrogen, that one's from this hydrogen, this one's from that hydrogen, and that one's from that hydrogen. So now look, this hydrogen has 2 electrons if you consider them sharing. Whee! And this one has 2 if you consider that they're sharing. Whee! This one will have 2. So the hydrogens are all going to be happy. And if you look at the carbons, it's kind of hard to look at the carbons now, isn't it? See if that'll erase it. Oh, look at that. If you look at the carbons, because they're sharing an electron with each hydrogen, now they have 8 altogether out here, so they're stable too.
Do the atoms for, like, do the electrons buzz around, like, the exact same way each time, or do they change electrons?
You know, I don't know. Yeah,
atoms?
I don't know a ton about this, except I know that it is statistical, so they look at the percentage of time that each electron is going to spend in each orbital. So an electron here, you know, is mostly going to be spending, in other words, if you take a snapshot of this, there's typically going to be maybe 1 electron on here, 1 out here, 1 around here, 1 around here. But will this electron maybe go over to that one someday? Yeah, sure. And if you look at a metal, actually, they really, their electrons can really spread from one atom to another. But just in here, yeah, those electrons can probably go, you know, around here and maybe whatever. But statistically, you're going to get 2 shared electrons between here and here, 2 between here and here.
Okay. Okay, good.
When atoms share electrons, it's called a covalent bond. It's really important that you know, that you know what a covalent bond is. So it's shared electrons. And this is a very strong bond. So you should write that in your notes. Covalent bonds are very strong compared to the other one that we're going to study, which are hydrogen bonds. So write that in your margin. That covalent bonds are strong. Carbon is very special because it can form how many bonds, Davy?
4.
Good. So each carbon can bond with 4 other atoms and make really big chemicals like this. This is DNA.
But look, there aren't any carbons in there, though.
I know. So here's the thing. Organic chemists get so sick of writing carbon because it's the basis of all life, and so they just don't even write it in where it is. So any spot that you see abandoned, that's really carbon. All these spots are carbon. So carbon is forming 1, 2, 3, 4 bonds. That carbon forms 1, 2, 3, 4 bonds. All of these spots where no carbon is written is carbon, because scientists won't mistake it for anything else because it's forming 4 bonds. So carbon, 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 and then some more carbon. Could you make, Davy, this is a question for you.
Okay.
Could you make this whole huge thing based on oxygen? Oxygen has just 2 bonds. If you can see that oxygen has 2.
It could not bond all the ways that carbon does because it only has 2 bonds.
Good. So if you look at the carbon right here, if that were oxygen, it could bond here and here, but then it wouldn't connect to this part of the molecule. So having those 4 bonds means that you can make these huge, huge, huge lattice work type molecules. And that's what your body's based on. Orange, orange, orange.